Part 2, so we will discuss how the pressure influences the equilibrium position. So first, this is how we analyze the disturbance. First, how to identify the disturbance, how to reduce disturbance, and the equilibrium position shift to the which direction. Okay, first, pressure decrease. So pressure decrease can caused by the volume increase. So this is a disturbance pressure decrease. So how to reduce the disturbance? You must increase the pressure. How you increase the pressure? You must shift to the side which is a larger number of mole. So what's meaning by larger number of mole? I will explain with you later on. Okay, second disturbance is a pressure increase. So the pressure increase is disturbance. So you need to reduce the pressure. So you need to reduce the pressure. How you reduce the pressure? Equilibrium position should shift to the smaller or lower or fewer number of mole. So which side is a less number of mole. So at the end, how about equilibrium constant K? So as you know, equilibrium constant K will change when the temperature change. So the factor we discussed today is a pressure. Pressure is not influence the equilibrium constant because the pressure is not temperature. That's why equilibrium constant for the pressure change, the equilibrium constant will be no change. Alright class, now we are using one example to explain with you how's about pressure increase and pressure decrease. Okay, now I give you this equation. 2A gas equilibrium with produced with B gas in the equilibrium condition. And the red color is A and the green color is B. And you will find that on the reactant side, this side, the total mole is 2 mole, and the product side, the reactant, the mole is 1 mole. We will count the total. Okay, now you can check. This is at equilibrium. So at equilibrium, so you can see, you can find the 8 number of the A and the 4. The green one is a B is a 4. Now, how about the disturbance? Okay, now what happened now is you decrease the volume. So when you decrease the volume, meaning that your pressure increase. So this is why we call disturbance. Okay, disturbance. So you can see the volume decrease. Then you can find that you can count the number of red and the green. You have found that it's a more green color, right? It's a more green color. So today I will explain to you why more green color. So more green color means that you produce more B. So why they will produce more B when they increase the pressure? Now I will show you. So once the disturbance is a pressure increase, so how you reduce the disturbance is you must decrease the total pressure. Here you must decrease the total pressure. How you decrease it? We must decrease more of the gas. Why? Because P total equals to N total VRT. If you able to decrease the more of a T total, meaning that the P total also will decrease. So check the equation. Left side is a 2 mole and the right side is a 1 mole. So we'll shift to the right side because 2 to 1. 2 to 1 meaning that the number of mole is more smaller. So that's why you will shift to the right side. Okay, so that's why you will produce a more green color B. Now, second disturbance is a volume increase. Then you will know the pressure will decrease. So this is your disturbance. So pressure decrease. So volume increase, that means you'll get the more larger volume. Okay, you can find that why will produce more red color compared to the equilibrium, right? Yeah, compared to equilibrium is a more red color and the green color is a less. That means that the system is a shift to the left side because you can produce more red color. So why the system will shift to the left side? Okay, now we discuss the theory. So the disturbance is a pressure decrease, meaning that you must increase the total pressure. So you must increase the total pressure. To increase the total pressure, you must increase the total mole of the gas. Look at this formula. So if a number of mole total increase, that means that the P total will increase. How we increase the number of mole? Okay, now look at this equation. 2 mole gas on your reactant and 1 mole gas on your product. So equilibrium portion will shift to the left side. So why they shift to the left side? Because they change from 1 to 2. 1 to 2 meaning that the number of mole increase. Another meaning is a more number of mole. So that's why once they shift to the left side, you produce more A. So you can see a lot of the red color A at this condition. Okay, for next slide, I will discuss you how to do the analysis and explanation from the equation given. Okay, now for first step, this is a concentration. So I will count how many more of the reactant is a 2 and how many more on the product is a 1. Okay, now increase the volume, disturbance is increased volume. Increased volume means the pressure of system will decrease. So this is a disturbance pressure decrease, meaning that how to reduce the disturbance, you must increase the pressure. So how you increase the pressure, you must shift to the larger more of gas. Okay, now you look at the equation. So which side will produce more larger more of a gas? So this is a 2 and then this is a 1. If I shift to the right side, you produce less. 2 to 1 is less. But left side 1 to 2 is a larger more of a gas. So you will shift to the left side. So after I do the analysis, now we'll do the explanation based to the sentence. First one, when volume of system increase, the pressure of system will decrease. This is the first sentence. Second sentence is how to reduce the disturbance. The system will reduce the disturbance by increase the pressure by shift to the larger number of mole of gas or more number of mole of gas. Okay, now you check. So which is a more number of mole of gas? It's a reactant, right? It's a reactant. So you can say number of mole of a reactant is larger than number of mole of product. So equilibrium position will shift to the left. So amount of product will shift to the left, meaning that amount of product will decrease, amount of reactant will increase, and the K remain unchanged. Okay, how about the second factors is disturbance is you decrease the volume. So once you decrease the volume, the molecule will collect more frequent, so pressure of system will increase. So this is your disturbance. So pressure will increase. So how you reduce the disturbance? You must decrease the pressure. So decrease the pressure will shift to the smaller number of mole of a gas or less number of mole of gas or fewer number of mole of gas. So now you look at the equation from here 2 to 1. So when 2 to 1 is a shift to the direction less number of mole of gas, meaning that the answer from here is a shift to the right side. Okay, class, you just remember, understand the shift to the larger mole of gas or smaller mole of gas. Left and right is depends to the equation. Okay, now when volume of system is a decrease, the first sentence come from the when, so the pressure of system will increase. Second sentence come from the how to reduce the disturbance. The system will reduce the disturbance by decrease the pressure, which shift to the smaller number more of a gas. So now you can find where is a less number of mole of gas is a product side. So you can say number of mole of product is less than reactant. Okay, so equilibrium position will shift to the right. Okay, until equilibrium. So that's why once they shift to the right, amount of product increase and amount of a reactant will decrease and the K is constant. Now we look at the second example, H2 and I2 produce 2HI. Okay, now I will start to count how many more for the reactant and product. So for reactant, right, so you will get here 1, 1, and plus 1. So total is 2 more gas on your reactant side. And how about product? So product is 2 more. So you only count the gas and the all total reactant and product. Now, from the conclusion, you can find, or for observation, you can find that total number of mole of gaseous reactant equals to total number of mole of gaseous product. So just now, right, we learned you must shift to less mole or larger number of mole. But in this condition, mole of reactant and product is the same, meaning that changing of pressure does not influence the position of equilibrium for this case.